All right. Sorry about that, technical difficulties. So this is the review for Chapter 3 test. First off, what is a transversal? It is a line that passes through at least two lines. Okay. So for example, if I have a line and a line, that one's cutting through as a transversal. I have a third line here, but that one line is still the transversal cutting through those three lines. Now, after we learned about transversals, we learned there are special situations if the lines are parallel. There's certain relationships that happen. All right. So these here are the drawings of what it looks like. All right. So we're going to fill in some arc marks to show it. Corresponding angles. Remember, corresponding angles are one on the inside and one on the outside. I just said that backwards. So one on the outside here and one on the inside. Inside is between these lines. Now, that's not the only ones. You know, we have this one here and this one here. Okay. We have this one here and this one here. And we also have this one here and this one here. So there are actually 4 pairs of corresponding angles there. And those are going to be congruent. Now, alternate interior. Remember, alternate means either side of the line. Interior means it has to be inside, but in between those 2 lines there. Okay? Nothing out here and nothing out here, which is why I said many times it's good to kind of identify what's inside and what's outside. So alternate interior would be this angle here and this angle there. All right. Or this angle here and this angle here. Okay. And those are also congruent. Alternate exterior, same idea, except on the outside. So this one here and this one here, and then this one here and this one here. Both exterior of the 2 parallel lines on opposite sides, alternate sides of the transversal. These are also congruent. Now we have a new one here, consecutive interior. This one and this one here. I haven't been using 1 and 2 marks, but I definitely want to here to stress that one of these is usually going to be acute and one's going to be obtuse. All right. Or you have this one here, which alternate interior, the 2 reds are the same. And this one, oops, that's supposed to be green. It didn't change because alternate interior are the same. But consecutive are the red and the green. Consecutive means they're the next one in line and they're both inside. This one is a special one because this is the one where one is obtuse and one's acute, which means they are supplementary. They add up to 180. And then consecutive exterior angles. So we have not discussed this year. You can probably figure out what it means, where they are, just by the terminology, but we're not going to be testing on that. All right, on the next section here. It says in the figure to the right, tell what type of angles each pair is. Now, I need to talk about something here. It says vertical, corresponding, alternate interior, alternate exterior, and then this SSI. I've talked about this before in class. I've told you that consecutive interior can also be referred to as same side interior. And that's what SSI is. And we're not going to talk about SSE, same side exterior, which would be consecutive exterior. Okay? And then tell whether they are congruent or supplementary. We're assuming, well, we're given A is parallel to B and C is parallel to D. So before we get started, let's look at this. If we look at A and B, okay, these are my interior angles. Okay, those are all interior. But if I'm looking at C and D, these are my interior angles. So you have to be careful and figure out which way you're looking. But if you notice, 6, 7, 10, and 11 are interior no matter which. So those are always interior angles. Okay? And same thing with exterior. For the blue lines, 4, 5, 12, and 15, along with 1, 8, 9, and 16, are exterior. But if you're looking at the red lines, it's 1, 2, 3, 4, and 15, 16, 14, 13. And the only ones that are always exterior, no matter what, are on the corners, 1, 4, 13, and 16. So otherwise, it depends on which way you're looking at the angles. So you got to be careful when there's this many lines. So 1 and 9. So here's 1 right here. And if you think about it and just slide this bad boy down, 1 and 9 are the same angle. Now think about it. Are those acute or obtuse? I drew it kind of poorly, so let's fix that a little bit. But think about this. It's slightly, but you can tell. Number 1 is an obtuse angle. And think about it. All the obtuse angles will be equivalent. So 1, 9, 11, 3. Rotate this around. 5, 13, 15, and 7. All of these angles are going to be congruent. They're all the obtuse angles. Okay, so 1 and 9 are congruent. Whoops. And why? Well, again, look at it. If you look at lines C and D, 9 is inside and 1 is outside. Again, that's looking between at C and D. All right, and the way you know it is ride the transversal. This is the transversal here, and it connects or goes through C and D. So you want to follow the transversal, and then you'll know which lines you're looking for, interior and exterior. All right? So again, congruent, and those are corresponding angles. 2 and 6. Notice 2 is the linear pair, number 1, which makes it acute. And again, 2 and 4, 12 and 10. And then, careful here, 8, 16, 14, and 6. All the acute angles are the same. So 2 and 6, whoopsie, that was not what I meant to do. 2, and then 6 over here, which I already showed by kind of spinning this around in this fun, are both acute angles. They are congruent. Now, again, ride the transversal. 2 and 6 are on line C. C is a transversal, which means we're looking at A and B to determine 2 and 6 are alternate interior angles. We've been abbreviating. You can abbreviate even more now. Alternate interior angles. They are on either side of C, the transversal, and both in between A and B. Okay, 10 and 16. Well, 10, whoops, did not mean to do that. I've just messed this up, so I'm going to just kind of get rid of him and redraw it. Here's 10. It is an acute angle. And then we have 16, which is right here, which is also acute, and it's vertical, which means they are congruent. Now 7 and 10, let's look at this. This is where the common sense has to kick in a little bit. 7 and 10. Are they the same? No. 7 is obtuse, right? Whoops, did not mean to do that either. Okay? 7 is one of the obtuse angles. So we have an acute and an obtuse. They are not the same. We do not want to say they are equal to each other. And whenever we have a situation when they're not equal, that means they are supplementary. All right? And we can call this SSI, same side interior, or what we've been calling it, consecutive interior. And I will remind you on the test about those two being interchangeable. All right, 3 and 13. 3 is one of the obtuse angles, right here. 13 is also one of the obtuse angles. Now, they just kind of, you slide down this transversal B, which means we're looking at lines C and D, and 3 and 13 are both exterior. But one's on the right side, one's on the left side. So that means they are congruent because they are alternate exterior angles. All right, 7 and 15. Well, remember, we said 7 is one of the obtuse. And 15, if you slide down A, is also obtuse. So they are congruent. And they're congruent because one's inside C and D, one's outside C and D. And we're looking at C and D because A is the transversal we're writing on. So since one is inside and one's outside, that is corresponding angles. 5 and 12. At some point, it just is easier to do this and start over. So 5 we have right here. And 12 we have right here. Well, if you notice something interesting, 12 is the same as 10, and 5 is the same as 7 because of corresponding angles. Therefore, since up here on number 6 we said 7 and 10 were supplementary and SSI, again, this is the same thing. SSI or consecutive interior, which means they are supplementary. And last but not least, 4 and 14. Well, here we have 4, and 14 is down the same transversal on the opposite side, so that is congruent alternate exterior angles. That's a lot, but if you need to, you can always go back and play it again for more practice. All right, use the figure at the right, assuming given that E and F are parallel. So with this, it's hard to tell what's obtuse and acute. That's practically 90 degrees. So what you got to get used to looking at is, just remember, this one right here is going to be congruent to 6, right? And since 8 is a vertical angle to 6, then 4 is also going to be the same. So 2, 4, 6, and 8 are all the same. And there's nothing saying that you cannot go right now and saying, wow. Right now, if this was your test, you could look at that and go, okay, 2, 4, 6, 8, congruent. And then you could say 1, 3, 5, and 7, congruent. You could write that down. And then since there's not as many lines, you could say, interior are 3, 4, 5, 6. Exterior 1, 2, 7, 8. If you do spend the 30 seconds to make up this guide right here on this basic problem, it will make everything easy for you. So let's look at this. If I say that angle 3, we're trying to find 3 if 1 is 50. So here's 1. We know it's 50. Well, we just said over here that 1, 3, 5, and 7 are all the same. So I know that angle 3 is also 50. Specifically, why? It's vertical. Okay. Moving on. Find 6 if 4 is 17. All right. So 4. Obviously, that's not 17 degrees, but we're just going with it. Find 6. Well, 6 is an alternate interior angle. Up here, we said 2, 4, 6, and 8 are all equivalent. So therefore, it's 17 degrees also. See how easy this chart is? It helps you? Hopefully you do. Find 5 if 4 is 50. Oh, finally a mix-up. We have 50 right here. And then we have 5 right here. Well, remember, look at it. 2, 4, 6, and 8 are equal. 1, 3, 5, and 7 are equal. Therefore, 4 and 5 are obviously not equal to each other. Now, they don't look that different because this is not obviously, it's not like you had two lines like this and one came through real drastically and we could clearly see obtuse and acute. We don't have that here. This is probably more like, this looks like it might be, 95 and 85 here if it was really measured. So it's really close to 90. I think you can tell that the even ones, 2, 4, 6, 8, are slightly obtuse, and 1, 3, 5, 7 are slightly acute, but it's hard to tell. But remember, if you know that 2, 4, 6, 8 are the same, 1, 3, 5, 7 are the same, therefore 4 and 5 must be supplementary. Therefore, angle 5 is going to be 180 minus 50, which is 30 degrees. I'm sorry, I can't do subtraction. Math is hard sometimes. Equals 130 degrees. Those two add up to 180. They are supplementary. They are not equal. All right. If angle 6, which we think is probably slightly obtuse, but we are saying it's 87, find angle 2. Well, we already made our list, but angle 2 is corresponding, so therefore it's the same, so it's 87 also. And then find angle 8 if angle 2 is 109. Okay? Well, angle 2 is one of the obtuse ones. Find angle 8. Well, we're going to slide down the transversal, right? And then on the other side of the transversal, it's going to be equivalent. Alternate exterior angles. And we said up here, all the evens, 2, 4, 6, 8, were congruent. So also 109. Now, this handy chart right here can be used down here. Right? Now, they're not numbered, but we can kind of look at that and say, hey, this is like angle 1, angle 2, angle 3, angle 4. If you number it the same way, like this, so all the evens are one kind and all the odds are the other kind, like in this one, all the odds are obtuse. And I can do the same thing here and just copy this over real quickly to keep me on the same thing, and then guess what? I have a chart that tells me which ones are the same. So what do I have here? I have angle 1 and angle 7. Well, we know up here that they're all the same. So that tells me they are equal. I also know because they're alternate exterior, but I'm just giving you another hint to make sure you set this up correctly. Okay, now I want to keep my x's positive, so I'm going to subtract 3x from both sides. I'm going to show my work also so I don't mess up and make a simple mistake in my head. I'm also going to add 30 since I don't have a lot of room here. I'm going to do it all in one fell swoop. And that gives me 4x minus 3x is x. and 30 plus 2 is 32. But the beauty of math is I can plug this in and check it. Okay? 3 times 32 is 96. Plus 2 is 98. So I think this is 98 degrees. If I plug it in down to number 7, 4 times 32, okay? So I do 4 times 32, which is 128. And then if I minus 30, I get 98. So this answer checks out. You don't have to move on to the next problem until you've proven that one correct. All right, now the next one's a little challenging. We have 3 angles, but let's look at them. What are we trying to solve for? We have 4, 5, and 6. Okay, the problem is angle 6 has a y in it. It's kind of tricky. So we need to work with the x's, which are 4 and 6. Sorry, my bad. 4, 5, 3, 4. Yeah, 4 and 5. So 4 and 5, if we look at our chart up here, are not even. They're not congruent. They're not the same. That's one of those problems where I say 4x plus 13 plus 6x plus 17 equals 180. Sorry, I don't have a lot of room here. Now, remember, be careful here. Some of you are still like subtracting 4x. No, you join like terms. So 4x plus 6x is 10x. 13 plus 17 is 30. Equals 180. Sorry about that. I'm going to subtract 30, which gives me 10x equals 150. Divide by 10, and I get x is 15. Now in this problem, I have to plug in because I need to find out what this angle is right here. So I need to do 6 times 15 plus 17. Okay? So 6 times 15 is 90. If I add 17, I get 107. Which means this angle right here is 107. All right? Now, there's 2 ways to solve this problem. And I'm going to go over to a new sheet just to make it clear. Okay? So I have 7y plus 3 and 107. I have 2 ways I can set this up. Obviously, I have an obtuse and an acute. So they add up to 180. The other thing is, if I know this angle is 107, I can simply do 180 minus 107. Okay, so 180 minus 107 is 73, which tells me this angle is 73. And I know it's 7y plus 3. Now, I'm going to get the same answer no matter what. So over here on the left side, I'm going to add my like terms again. Remember, I'm not moving anything until I'm simplified. So that's 110 plus 7y equals 180. Oh, yeah. Yeah, 110. Now I'm going to subtract 110. That's going to give me 7y equals 70. Let's step over here for a second real quickly. If I do minus 3 right here, I'm going to have 7y equals, oh, look at that, 70. Now it's going to come together, divide by 7, y is 10. So I just want to show you there's 2 different ways you could do that problem. Neither one is better than the other. It's what your brain understands best. Find the value of x. Now this is tricky because now we have shapes. Well, not really. If we go back to what we've been doing, we have parallel lines right here, and we know that from these marks right here. And what we have coming through is what we have been working with, a transversal. So we can ignore those other lines, and we look at this. This angle here and this angle here are both in between the blue lines, aren't they? They're also on opposite or alternate sides of the transversal, which means these two angles are alternate interior angles, which we know to be congruent. So I'm just going to say x plus 28 equals 3x minus 30. Again, I'm going to show my work. Okay, I want my x's on the right side, which means I need my numbers on the left side. You can do this in 2 steps or 1 step. It's up to you. What that's going to give me is 58 equals 2x. 3x minus 1x is 2x. Divide by 2. X is 29. And again, I can plug that in real quickly. Just takes 10 seconds with the calculator. 29 plus 28 equals 57. So I think this angle here is 57 degrees. If I do 3 times 29, it's 87 minus 30. Well, look what I got. Also 57. And I can leave this problem knowing on the test when I turn into my teacher, I got it right. Same thing here. We'll go with the same colors again. Here are my parallel lines. Okay, and let's look at this as my transversal right here. So this angle here and this angle here are on the same side of the transversal, but they're both in between the blue lines. So they are same side interior or consecutive interior, and we know those are supplementary. So I'm not going to say x plus 14 equals 2x plus 7. All right? If you look at them, it's hard to tell. Okay? But one is obtuse, one is slightly acute. So I'm going to say x plus 14 plus the other angle are supplementary, meaning they add up to 180. Again, combine like terms. 3x. Combine 14 plus 7, 21. Now I can move things over and subtract 21 from both sides. Okay, so I do 180 minus 21, and I get 159, and that's equal to 3x's. But I don't want 3x's, so I'm going to divide by 3 and get x is 53. Once again, I can real quickly plug these in. 53 plus 14 is 67. So I think this angle is 67. 2 times 53 is 106. Plus 7 is 113. And now if I add 113 plus 67, do I get 180? You betcha I do. And so therefore, again, I've proven this correct before I move on. All right, now we just have a couple of proofs. Okay, so we start off with our lines. We say statement. That is statement, sorry. And reasons. Okay. So first thing we do always is we write angle 2 equals 3x plus 30. And angle 6 equals 9x minus 12. And those are both given. Now let's go over and look at angle 2 and angle 6. Angle 2 is right here. Angle 6 is right here. We've already talked about these. It's kind of the same setup. Angle 2 and angle 6 are alternate exterior angles. They are congruent to one another. Okay? So first off, we say angle 2 is congruent to angle 6. alternate exterior angles. Okay? Then we say 3x plus 30 equals 9x minus 12. And what do? We substituted in 3x plus 30 for 2, 9x minus 12 for 6. And now we're going to go back to the very first type we learned how to do, which is to solve algebra. So I'm going to subtract, technical difficulty there. I'm going to subtract 3x, and I'm going to say subtraction property. And that gives me 30 equals 9x minus 3x is 6x minus 12. And remember, we just call this simplify. Now I'm going to add 112 to both sides. We're just solving algebra here. And that's going to give me 142 equals 6x. We did the addition property. Sorry, I skipped this. And now we just simplified. And now if we divide by 6, some of you are probably screaming at me already because I made a mistake here. This was minus 12. I don't know why I added 112. I don't know where I thought I saw an extra 1 or 100 there. So this is add 12, which means it's not 142, it's 42. And now if I divide, so that's division property, I end up with x equals 7, 7 equals x, and that is simplify, and I'm done. Now technically, you could rewrite it as x equals 7 by reflexive property, but it doesn't matter what side the x is on. You can stop right here. If you want to say x equals 7, go for it. Okay, we're going to skip this one. A little more complicated than it need to be in preparation for the test. So you know that. All right, so for this one, well, we're going to skip this one also because, as you can tell, there is no angle 10. This got cut off, so we're just going to leave that one off there. And we're going to skip this one and just end up with 22. All right, so we're given, here's our statement, here's our reasons, I'm just going to abbreviate. M is parallel to N, and P is parallel to T. Given. Okay, and we have our marks here. We know they're parallel, and we know these two are parallel also. Okay, so everything's parallel. We're good to go playing with what we know how to do. Prove 9 is equal to 8. Okay, so angle 9 right here, we need to have a choice. And there's going to be the possibility of going down this way and then going to 8, or we could go this way and go to 8. So let's just talk about it before we do any proofs. If we went 9 to 1, we would say 9 and 1 are congruent because they are corresponding angles. Then we could say 1 and 8 are congruent by alternate exterior angles. And then we would use the transitive property. All right? We could also say that 9 is congruent to 13, again corresponding, and then 13 and 18, alternate exterior angles. So either way, we're going to actually say the same thing and use the same rules. It just depends which direction you want to go. So I'll flip a coin here. Not really. I'm just going to pick one, and I'm going to go 9 to 13. So I'm going to say angle 9 after I have my marker. angle 9 is congruent to angle 13. And we just say corresponding angles are congruent. Then we're going to say angle 13 is congruent to angle 8. Alternate exterior angles are congruent. And then I can say angle 9 is congruent to angle 8 by the transitive property. And that's it. All right, so extra review for the test. Slope is y minus y over x minus x. You'll be able to use the formula to calculate that. Remember that parallel slopes are congruent. Perpendicular slopes are opposite reciprocal. So for example, 3/4 and -4 over 3. One positive, one negative, flip it. 1/2 and flip it. 2 over 1 or just 2 and make it negative. All right. Now, we did these in class. Just going to review it. If I give you a line, y equals 1/2 x plus 3. Okay? And I say I want you to give me the equation of a line that is parallel and goes through 4, -3. Okay? Remember, this is x, this is y. Now, first off, we want to identify the slope. M is 1/2. If we're looking at parallel, that means this slope will also be 1/2. At this point, we just take these 3 pieces of information, we write our equation, which is on the test, and we just fill in what we got. Y is -3. M is 1/2. X is 4 plus B. -3 equals half of 4 is 2 plus B. Now we just solve for B. -2 minus 2. B, whoops. B is -5. Now, we have the slope up here. We know it's 1/2. We know x, we don't know x, sorry. And we know our slope, our y-intercept, -5. Or we just put y equals 1/2 x minus 5. So again, it's very simple. We identify the slope of the line given to us first. If we are told to find a parallel line, that means we need the exact same slope. And whatever point they tell us is going through, that's our x and y. I suggest you label them. And then you write out the skeleton of the equation and just fill in y, m, x, and solve for b. Now, you might also be given one like this. Y equals -2x plus 1. But this time, I want a perpendicular line that goes through 6, 1. All right? Well, first I identify this slope as -2. I don't want that slope. I want the perpendicular slope. The perpendicular slope is opposite, so instead of negative, it's going to be positive. And instead of 2 over 1, it's going to be 1/2. Now, that's all I need. I don't need this anymore. So what do? I start off always by writing the equation. Now I just fill in what I got. Y is 1. Remember, if it helps to label it, do so. M is 1/2. X is 6 plus B. 1 equals half of 6 is 3 plus B. Subtract 3, I get -2, which means the equation of my line is y equals 1/2 x minus 2. So again, you're given the equation of a line, identify its slope. If it's perpendicular, change the slope to opposite and flip it. Opposite reciprocal. Then the same way, start off with the equation, fill in y, m, and x, solve for b, put m and b into your equation. All right, so finding slope. If I give you 2 points, 4, -2, and -3, 5. And I give you another 2, 5. Oh, it's supposed to be 7, so I'm just going to make it +7. And 4, 8. Sorry, my pen is acting up. I do the equation, which is y minus y over x minus x, both times. It's driving me crazy. So I fill in, I identify my x and my x and my y. Remember, very important, y is on top, okay? So on the top, my first y is -2, my second one is 5, so I just do -5. But careful, on the next one, my x's is 4 and -3, it's still minus, which means this is really plus. So what I end up with is -7 over 7, which is -1. That's the slope of that line. On this one, 7 minus 8, 5 minus 4. No double negatives. 7 minus 8 is -1. 5 minus 4 is +1. This also has a slope of -1, which means they're parallel. Last but not least, you might be given equations like 3x minus 2y equals 12, and compare it to y equals -2/3 x plus 1. You can't tell me whether they're parallel or perpendicular right now or nothing, because this one is not in the proper form. We need to move this over by subtraction. I don't know why I put 3/2. -3x plus 12. Then I need to divide by -2 on everything because I need the y by itself. So that gives me y equals negative divided by negative is positive, x minus 6. The slope of my line is right here, 3/2. Over here, this one's already done for me. I just need to identify my slope, -2/3. One's positive, one's negative. 3/2 is the reciprocal of 2/3. So these two are not parallel. These two are perpendicular. And that's it.